So this is the third week of our class, and here we are on chapter 3, data description for Math 092, which is a support class for Math 135. As always, we are going to start with the big goals for this course. And the big goals of the course, they will always remain the same. That is, in this course, we are going to explore some prerequisite skills for Math 135. And then we'll also work on improving these skills for Math 135. Then we'll talk a little bit about the study skills that they are related to Math 135. So these are the big goals. Now let's see what study skills I have for you for this week. So here they are. As always, make sure you stick with your schedule and don't fall behind. That is, try to complete every exercises or every assignment on time for both Math 135 and Math 092. Next week is your midterm exam. I hope you know that. So next week, try to complete the note catcher and mastery exercise by Thursday so that you will have Friday, Saturday, and Sunday to complete that midterm exam. And midterm exam will be a timed exam. So you have to complete within given time frame, maybe up 2.5 hours to work on that. You'll get more information on the midterm exam coming Monday. You'll see the information in the announcement, and also you'll find the information about midterm exam during the live Zoom session on Monday. So make sure you remember this. You have midterm exam next week, and next week you need to work a little fast. So try to complete the note catcher and mastery exercise a little fast so that you'll have time to work on the midterm exam. So complete your midterm exam in one of the 3 days. You can work on midterm exam on Friday, Saturday, or Sunday. But once you begin, you have to finish it. Once you begin, you have to finish it. You cannot go back and rework on it. So when you have 3 hours time, you sit and work on that. Any question here?
3 hours. This is for lab.
That is.
Or is it together like statistics class and lab, or it's just lab?
For the lab class, you will not have the midterm exam. There will only be the final exam for the lab. So there is no midterm exam for the lab. Midterm exam is only for Math 135.
Oh, okay. And it's gonna be 3 hours, right? So,
it'll be, yeah, 3 hours, yes.
Okay, yep. Thank you.
Okay, let's go to the example. So if you have your note catcher with you, you can make your note catcher ready. Make sure you have your calculator ready. So you may have to do some calculation. So we are going to start with the examples now. So here is the first example. You can see, find the average of the following numbers. So the numbers are given there and we have to find the average. So you can see the frequency is not given there. So this is the on-group data. For on-group data, you have the formula for the mean. Let me write for on-group data. On-group data. The mean is sum of all x, or sum of all numbers, divided by n. That is, if you add all these numbers, what you will get? Please add these numbers in your calculator: 24 plus 55 plus 40 plus 15 plus 60 plus 23 plus 20 plus 49 plus 10 plus 52. When you add all of them, what did you get? Are you working on your calculator?
Yes.
Okay.
34.
34 when you add all these numbers?
That's the full answer. That's the full answer.
Okay. When you add all these numbers, I think it is 348. Is that right? Yes or no? Yes. And you are dividing this by how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? You are dividing this by 10. So when you divide this by 10, what you will get? X, or mean, equal to 348 divided by 10 is 34.8. Is that right? Did I get it right?
Yes.
Okay. Okay. So all you have to do is you have to add all those numbers and then divide it by the number of observations. In this case, you have 10. So you divide by 10 and you obtain 34.8 as the mean. So this is the simple case. This is the mean of on-group data. So remember, this is the calculation of mean of on-group data. Mean of on-group data. You can see we are looking at the basic skills that is required in Math 135. You must know how to find the mean. So we are working on that here. So if you don't have any question on this, we are going to move on to next question. Ready for the next question? Yes, no?
Yes.
Yes. Okay, here is the second question. You can see there are a lot of words there. A student is trying to compute her average in a class that consists of 3 quizzes, a midterm, and final. Her quiz grade are 86, 78, 79. Her grade on the midterm was 72, and on the final, it is 64. The professor's syllabus states quiz 10% each, midterm 30% of the semester grade, and final exam 40% of the semester grade. We have to calculate the average in the class. So we are calculating the average, but the weight for each is given. The weight for each quiz is 10%, weight for midterm exam is 30%, and then weight for final exam is 40%. So because the weight is given here, and we are asked to find the average, this is the problem on weighted mean. This is the problem on weighted mean. Okay, and if you remember the formula for the weighted mean is equal to sum of x times w divided by sum of w. So the value, x value multiplied to the weight, and we add all of them. So here, if you look at the weight, these are the weight in quiz. This is the weight on midterm exam, and that 164 is the weight on final exam. Now for the quiz, the weight is 10%, right? The percentage, it's 10%. It's 30% for the midterm and 40% for the final. So if you want to add all these, how do we do that? Let's use the formula. X bar equal to sum of x times w. We have to do x times w and add them together. So for 86, the weight is 10. So how much is 86 times 10? 860, right? And then for 78, the second quiz, the weight is still 10%. So 78 times 10, which is 780, plus the third one is 79, but the weight is 10 because that is also the quiz. So 79 times 10, that is 790. Then plus, let's go to midterm exam. 72 is the score on midterm exam, and the weight is 30. So we have to multiply 72 times 30, which is 2160, plus final, the student got 64 and it is 40%. So 64 times 40 is 2560. So we got the numerator, which is the sum means this plus sign of x times w. We did all this x with that w, this x with that w, this x with this w. Now we have to divide all these by the total weight. So 40 plus 30, 70, and there are 3 quizzes, 10% each, 3 times 10, 30. So you can see there are 3 quizzes, 10% each. So that is 30, this is 30, 60 plus 40 is 100%. Does that make sense? Just say yes or no.
Yes.
Okay. Now add the numerator. Add everything on the numerator. That is 860 plus 780 plus 790 plus 2160, 2560. I got, if I add all those, I got 7,150 divided by 100. which is equal to 71.5. That is a C, right? You can see if you look at this score, in one quiz, the student got a B. Then after that, this was a C. This is a C. If you look at the final, it is a D, but the student managed to keep the average at low C, 71.5%. I think I collected this data a couple of years back, and this is the real data of a student. Okay. Any question on this one, on weighted mean?
No.
Okay. We'll go to next example. Here is the other example. So in this one, you can see they have given the class, they have given the frequency, and we're asked to compute the average number of minutes of sorting. So this is our next case. That is, here we want to find the average of this group data. So average of group data. Average or mean of group data. Group data. And if you remember the formula for the average of the group data, X bar equal to sum of F times X or M. Here we have the class, so F times M divided by N. So what we need is, we need the frequency, we need the mid value, and we have to multiply that. So we are going to make a table here. First, we are going to find the mid value, M. Then we are going to write the frequency F. And then we are going to find F times M. In next column, we are going to find F times M. And we are going to add them. So when I say M, M is the midpoint of this class. So if you want to find the midpoint of this class, you can follow along with me. 0.0 plus 10.4. So we add the lower limit, upper limit, and divide the sum by 2. So add 0 and 10.4 and divide it by 2 in your calculator. You should get 5.2. Next, 10.5 plus 20.9 and divide that by 2. I got 15.7. Make sure you do it in your calculator. Third, 21.0 plus 31.4 and divide that sum by 2. I got 26.2. I got 26.2. Next, we have 31.5 plus 41.9. Divide that sum by 2. I got 36.7. Next is 42.0 plus 52.4. Divide that by 2, and I'm getting 47.2. 47.2. Next, we have 52.5 plus 62.9. Divide that sum by 2, and the result should be 57.7. Make sure you check it. 57.7. And the last one, 63 plus 73.4, and divide that sum by 2, I get 68.2. Make sure you also add those numbers and check them. Do you have any question on how we find the midpoint?
No.
Okay. Now in next column, we have the frequency. So we are just copying these numbers, which is 10. Then we have 19. Then we have 11. Then we have 8. Then we have 9. Then we have 1. Then we have 2. You may add these frequencies, 10 plus 19 plus 11 plus 8 plus 9 plus 1 plus 2 in your calculator. I got 60. So when you add all frequency, that is the total value. So you can say N equal to 60. Now, in our formula, we need N. We got that N here. We need F times M. So we need to multiply F and M. Like here, we are multiplying 10 times 5.2, which is 52. Do that in your calculator. Next is 19 multiplied to 15.7. It is 298.3. Then multiply 11 times 26.2. You should get 288.2. That's what I'm getting. Next, we have 8 times 36.7, which is 293. Okay, let me see again. Yes, 293.6. That's good. Next one, we are multiplying 9 with 47.2, which is 424.8. 424.8. Next is 1 times 57.7, that is 57.7. 57.7. Then 2 times 68.2. 2 times 68.2, do it in your calculator, I get 136.4. So what we did here, we got the mid value, then we have the frequency, we are multiplying frequency with the mid value, and we got these numbers. And if you look at the formula, we need the sum of f times n. That is, we have to add all these to get the sum of f times m. And if you add all those numbers using calculator, you should get 1551, but make sure you check it. So we have everything ready here. Okay, we have everything ready. Now all we have to do is we have to use this formula and find the mean. So now the mean is equal to sum of f times m. We got that value here, 1551. 1551. And we divide that by n, which is 60. Which is 60. So this implies your mean is equal to, if you divide that using calculator, you get 25.85. 25.85. And this is the number of minutes they shop online. So we can write minutes for the unit. You can write minutes for the unit. So that is the mean of the group data. So you can see in these three examples, in this one, we work on mean of group data. In the previous example, we work on weighted mean. And in the first example, we work on mean of on-group data. So we look at three different cases in calculation of mean. Do you have any question in this third example? Just say yes or no. Anybody can unmute and say yes or no. Okay. Then we'll move on to next example. It's not that difficult. We are just looking at the concept that we have done in the previous class that you must know, okay? So we are refining the concept for next class. Here is the other one. Assume the data is normally distributed, apply the empirical rule. You already know that we can use empirical rule only for normally distributed data. And when we say empirical rule, it is that rule where we talk about 68% within one standard deviation, 95% of the data within two standard deviation, and 99.7% of the data within three standard deviation. That is the empirical rule. When you say empirical rule, you must remember that. So here in a sample of 200 adults, so this is your n equal to 200. The mean or the average nighttime sleep was 6 hours. This is the average, okay? Mean. Average is 6 hours with a standard deviation of 10 minutes. That is the standard deviation S. Standard deviation is 10 minutes, but the total number of sleep is 6 hours. So this is in hours and that's in minutes. So make sure you write everything in minute. So 6 hours means how many minutes? 6 hours is equal to, in 1 hour you have 60 minutes. So if you multiply by 60, that is equal to 360 minutes. And we want to apply the empirical rule. So for that, we need to draw the normal curve. Please draw the normal curve. Draw the normal curve like that. The bell-shaped curve with the mean in the middle. With the mean in the middle, which is 360 minutes. Now, if you want to go one standard deviation up and one standard deviation down, when you go one standard deviation up and one standard deviation down here, standard deviation is 10, so 360 plus 60, that is 370. And then 360 minus 10 is 350. 350. So this much data is within one standard deviation. And we know that in one standard deviation, we have 68% of the data. So this data is 68%. So your first answer will be approximately 68%. Okay, approximately 68% of adult sleep 350 to 370 minutes. That is the meaning of that. Okay, because this is the sleep time for 200 adults, and we saw that 68% of them sleep 350 to 370 minutes, because that is within the one standard deviation. Now let's go to two standard deviation. So when you go one standard deviation up now, this will be 370 plus 10, 380. And when you go one standard deviation down, this will be 350 minus 10, that will be
340.
Yes. So these two data value are within two standard deviation, which is 95%. Okay. So you can say 95%, approximately 95% of the adult sleep 350 to 370 minutes. I mean, 340 to 380 minutes. So let me write that. Approximately 95% of adult sleep 340 to 380 minutes. That is the meaning of that. We have one more to go. So we'll go one standard deviation down and one standard deviation up. So when I go one standard deviation down here from 340, it will be 330, 330. And when you go one standard deviation up, it will be somewhere there. And that will be 380 plus 10, 390. So the amount of data that is within this three standard deviation is 99.7%. So you can say approximately 99.7% of the adults sleep 330 to 390 minutes. So let's write that. Approximately 99.7% of adult sleep 330 to 390 minutes. So that is the idea of the empirical rule. So in this example, we learn how to apply the empirical rule. Always remember, when we talk about the empirical rule, it is 68, 95, and 99.7% rule. Any question in this one?
No.
No question. Okay, great. We'll go to next example, and next few examples are similar. And this is related to the box plot and 5 summary number. So this is related to box plot and 5 summary number. Box plot and 5 summary numbers. It's not that difficult. Let's find out. So what is given here? The following box plot for the number of minutes a group of students spend commuting from their homes to school on a given week is given. How much time they need while going from their home to school, and based on that, they have drawn the box plot here. We have to find the 5 summary numbers. When we say 5 summary numbers, we are looking at the minimum data value. I hope you have watched the lecture video in the module and you have the idea of this. Minimum value, the first quartile, the second quartile or median, then the third quartile, and the maximum value. These are the 5 summary numbers. Okay, 1, 2, 3, 4, 5. So the minimum value is this one. In this box, this line which is here is the whisker. So what is there at the end of this whisker? What number is there? Look at the graph and tell me what you see.
25.
25. So that is the minimum value. So minimum is 25. Now the first quartile is the left end of this box. What number corresponds to this value here? Everybody look at the graph. What numbers corresponds to
100.
that? What do you see?
100.
100. That is your first quartile. The median is here in the middle. This vertical line represents the median or second quartile. So what is the median or second quartile? Read the graph. What is there?
125.
125. Very good. 125. Then the third quartile is this one. Third quartile is this. So what is here? What number corresponds to that value over here? What do you see?
175.
175. 175. And what number corresponds to this value here? What is that? That is the maximum value. What is that?
200.
200. So you're just looking at the box plot and you are finding the 5 summary numbers. So these are the 5 summary numbers. Sometimes you may have some additional question like, let me add one. You can also add this question. Suppose the question is, what percent, you can write this question, what percent of data lies between 100 and 175, for example. So how much data is here from 100 to 175? If you look at this, these numbers, Q1, then Q2 and Q3, this divides the data into 4 equal parts, 25 up to 100, one part, 100 up to 125, another part, 125 up to 175, another part, 175 up to 200, another part. So these are all equal. So this is your 25% from here to here, that's another 25%, from median up to here, another 25%, from here to here, it's 25%. So if we go from 100 up to 175 here, you can see from here to here it is 25, and then from the middle up to there is 25. So how much is 25 plus 25?
50.
50. So 50% of data lies between 100 and 175. So you can say 50% of data, 50% of data lies between 100 and 175. Does that make sense?
Yes.
Okay. We have 10 more minutes before the session ends. After the session ends, we'll log back again after 10 minutes, okay?
Okay.
Okay, here is the other one. We are asked to do the same thing. We are asked to find the 5 summary number. That is, we are looking for minimum, first quartile, second quartile or median, third quartile, and the maximum value. I want all of you to look at the picture and answer the question. What is the minimum value? Please read there. Minimum value is 0, right?
0. Mm-hmm.
0, okay. What corresponds to this one, the first quartile? Read that number there in your note catcher or here in the screen. Is that 100?
100. Mm-hmm.
Okay. What is the median or Q2? This is the median or Q2. What is that value? Look at that.
200.
200, very good. What is the third quartile, Q3? What value corresponds to this? That's your Q3.
300.
300, right? 300. And what value corresponds to the maximum value? What is there? What is the maximum value?
It's 900.
900. Now you have seen in the lecture video, if this whisker is long to the right, here it is long to the right, meaning of that is this data is skewed to the right. If this whisker is long to the right, the data is skewed to the right. If this whisker is long to the left, it will be skewed to the left. But in this one, the whisker on the right is long. So if they ask about the skewness in this data is skewed to the right. Okay, that is just for additional information, but you can write it down. This data is right skewed. right, skewed. But if you look at the previous example, you can see this one, in the previous example, this is skewed a little bit to the left because it is longer on the left. But in the second one, it is skewed to the right. Okay, let's do the last example here. And you can see that this one looks, the whiskers are equal on both sides. So this is not skewed to the left or right. This is normal. Okay, this is normal. That is why the whiskers are equal on both sides. That is the normal distribution. But our question here is not to talk about the skewness, but we need to find the 5 summary number. So we are interested in finding the minimum value, Q1, Q2 or median, Q3, and maximum value. So by looking at this data, I want all of you to look at the screen and answer the question. What is the minimum value? Read the graph and tell me what is this minimum value?
50.
Minimum value is 50. What is our Q1?
100.
100, very good. What is our Q2? Read that.
125.
125. What is our Q3? If you read that. 150, very good. And what is the maximum value?
200.
200. Maximum value is 200. So if you look at your note catcher, this is the last example that we have. So what we are going to do is we are going to take a 10 minutes break and we'll come back. We are going to end the session now. We'll come back in 10 minutes and we'll talk a little bit. Is that okay?
Yes.